Welcome back again. So now here we want to solve this double integral. Our integrand is y times sine of xy, and now we are given this region R. This is a rectangular region. Our rectangular region is given by this Cartesian product. So basically this interval represents the x values, and this second interval represents the y values. So if I draw it here, your y goes from 0 to pi and x goes from 1 to 2. Okay. And now this dA is the area element on the xy plane, and let me draw this domain of integration on the xy plane. Y goes from 0 to pi, so y equals 0 is here. Let us say this is the value of pi, and then x goes from 1 to 2, and now your domain of integration is this, and this is your region R. Now if you consider a rectangular element like this, this is your dA. Now what you can do is you can think the length of this element dA as dx and height as dy. So dA equals to dx dy or dy dx, because this is a rectangle and area of a rectangle is length times width. Okay. So to solve this integral, say we have two options. Our option 1 is this y sine of xy. Now let us say dA is the area element on the xy plane, and it is dx dy or dy dx. Let me do this. So this is your area element dA, just dx dy. Our second option option 2 is this. Now initially we used dx dy, but now we are going to use dy dx. Okay. Now if you think about this option 1, what are the limits of these two integrals? Okay. So my inner integral corresponds to the x variable, and x goes from 1 to 2, and y goes from 0 to pi. Okay. Again, so this variable of integration is x and y, so dx dy. Inner integral corresponds to the x variable, and x goes from 1 to 2, and outer integral corresponds to the y variable, and y goes from 0 to pi. But if you consider this order of integration, so first we integrate with respect to the y and then with respect to the x variable. Now our limits are y goes from 0 to pi, x goes from 1 to 2. Okay. Now you can use either option 1 or option 2, both methods are correct, but in this example I am going to choose option 1, and you can try option 2. Okay. Okay, so now as I said earlier, we are going to solve this double integral using our option 1, and in this option 1 my order of integration goes like this. So my first I am going to integrate this function with respect to the x variable and then with respect to the y variable. Okay. So let us do this. Now if we consider this inner integral, our variable of integration is x. So it means we have to treat y as if it is a constant. Now, here we have a product of two functions y times sine of x y, and what we can do is we can pull out this y from the first integral. Then you will get integral from 0 to pi of y times integral that goes from 1 to 2 of sine of x y dx dy. Okay. Now, integral of sine is a negative cosine. Okay. So, we have negative cosine of x y, but with respect to the x variable y is a constant. So, integral of sine x y should be minus cosine x y over the constant which is y. Now we have to evaluate this result at x equals 1 and x equals 2. Your lower limit is 1 and the upper limit is 2 dy. Okay. Now, see, in the numerator I have y and in the denominator I have y. So, what we can do is we can cancel this y with this, and now we have a very simple integrand, just this minus cosine of x y, but still we need to evaluate this function at x equals 1 and x equals 2, then we have to integrate with respect to the y variable. Okay, so apply the upper limit first. You get minus cosine. Now, x equals to 2, so you have minus cosine of 2y minus, and then minus cosine of, so x equals to 1, so we have y. Now, this is your new integrand. This is your new integrand that you get after the first integral. Okay, now, if you want, you can distribute this negative, and then you have plus cosine of x y. Okay, let us do that. Minus cosine of 2y plus cosine of y dy. Okay. Now, here we have a single variable integral. So, basically we have an integral of a sum. Integral of a summation equals to summation of the integrals. Okay. So, if you integrate cosine, you have negative. So, if you integrate cosine, you will get sine. So, basically you have minus sine of 2y over 2 plus integral of cosine is again sine, and we have sine of y. Now, we have to evaluate this at y equals 0 and y equals pi. Okay. Apply the upper limit first. You will get minus sine of 2 pi over 2 plus sine of pi. Okay. This part comes from the upper limit minus the lower limit, minus sine of, now y equals to 0. So, 2 times 0 is 0 over 2 plus sine 0. Okay. Good. Now, again after we solve this inner integral, we apply these two limits, and then we got this expression minus cosine of 2y minus cosine of y, and here we simplified this integrand. So, basically what I did was I distribute this negative times negative becomes positive. Okay, and then integral of a sum equals to sum of the integrals. So, we have negative integral of cosine should be sine of 2y over 2, because here we have a constant, and when we integrate, so let us make a note. If if you integrate cosine of k x, let us say k y, with respect to the y variable, your answer should be sine of k y over k. Okay. Now, so we have minus integral of cosine is sine of 2 y over 2 plus integral of cosine y is sine y, and then we need to apply this upper limit which is pi and the lower limit which is 0. If you do that, you will get this expression, but sine 2 pi equals to 0, sine pi is 0. So, this part equals to 0 minus sine 0 is 0, again sine 0 is 0, and the second part is also 0. Now, the value of this entire double integral equals to 0. Okay. So, with this I finished the example 12.1.3, and yes, thank you.